So in terms of metals and alloys, the characteristic of metals and alloys is they have good ductility, So you can easily make into square, into sheet, like reasonable strength, reasonable the high temperature, low cost, very low cost. And those are the primary reason for metals to be used. Typical property also include good corrosion resistance, good wear resistance. Wear is wear, good 抗磨耗性 wear resistant. Okay. The other type of most often seen metals, alloys, is aluminum. And aluminum has advantage of lightweight. So 1 pound of steel, you can make a certain structure, rod or something. But 1 pound of aluminum, you can have 3 times more in volume. And when we are building some structure, it is the volume. It is not the weight that it counts, right? The only problem for aluminum, like 1 pound of aluminum give you 3 times more structure than steel. But the problem of aluminum is it's relatively soft compared with steel. So people try to make aluminum stronger and stronger, and that's what, if you look at the aluminum have different kind of grade. They add in alloying element to make it stronger, like aluminum, you add it in copper, you add it in zinc to make it stronger. You add it in silicon to make it stronger. That's just like this, so that the dislocation can move. And when you use aluminum, they also always have to be heat treated. It's called heat treatment. What is the purpose of heat treatment? Well, heat treatment is to create precipitation, create different kind of precipitation. So like aluminum, one grade of aluminum is called 2024 aluminum alloy. Okay, another grade is called 6061 aluminum alloy. The higher the number, typically the higher the number, the stronger that aluminum alloy. So in aerospace, airplane, the aluminum alloy typically are 6061, 6000 series, or it's 7000 series, like 7075. That's even higher. It's typically considered aerospace alloy for aluminum. Stronger, lightweight, stronger. But of course, no matter how strong, it is not as strong as steel. That's what people then start to say, oh, if you cannot make aluminum by heat treatment to create precipitation hardening, then maybe we should make composite out of aluminum. So aluminum composite become the most developed composite material in metal makes this composite. So before Michael Chen used graphite racket, it was not wood. Before graphite racket is available, there is aluminum racket. And you probably heard that the baseball bat, when I was a child, the baseball bat is what? Wood. Even up to in the college, the baseball team used wood bat. Okay, wood. Then they are using metal bat. Now a lot of them use metal bat, especially for softball. If you go to the field in there, you see the student hitting the ball. Those are pretty much aluminum bat. The tennis racket, same thing. There was one time aluminum racket, because aluminum is easy to make it into the shape of the tennis racket. So they use aluminum racket. And then a graphite racket is available, so people use graphite racket. So aluminum is made into composite, and NASA use a lot of good structure in space. In the space station, use aluminum composite in there. I have some photos. A little while, I'll show you what kind of material they use out in space. Okay. Another class of ceramics. Ceramics material typically have the property of good insulation, good heat resistance. So, you know, brick. In the building, we use brick. In the blast furnace, because temperature is so high, inside here, they have brick lining in here, because good thermal insulation. Typically, it has good electric insulation also. That's what, if you ever look at your engine, the spark plug, 火星山 spark plug, there are alumina, Al2O3 in there. You have positive and negative inside, in between. You have alumina in it. That's ceramics material. Good electric insulation. Typically, good insulator. Typically lightweight. That's what in the 80s also, people are trying to develop engine using ceramics engine. You heard of that? Ceramics engine. Why do people want to use ceramics engine? You remember engine, diesel engine? You remember Carnot cycle? You remember thermodynamically? The way engine operate is you have the way engine operate is purely thermodynamics, by the way. You remember a term called heat engine? In thermodynamics, first law of thermodynamics, you probably remember that. You have TH, QH come down. This is the engine. This is the work comes out. QL comes in, and this is TL. And the efficiency is W over QH. Remember that? And W pretty much is QH minus QL. This is the first law of thermodynamics. Okay? Heat engine. The Carnot cycle is PV in here, and you have a isothermal cycle, and you have adiabatic cycle. This is isothermal, and this is adiabatic, and the region in between is the work in here. Okay. Based on this, and this is then related to TH minus TL over TH. If you remember that. So the higher the TH, the higher the temperature of engine. TL is room temperature, pretty much. The higher the TH, the higher the efficiency. Okay, so that's what in the 80s, a lot of engine company and ceramics company, they also try to make ceramics engine. The reason is ceramics engine, you can operate at higher temperature. So that'll give you better efficiency that way. Okay, and that comes from that heat engine concept. But ceramics, although if you make engine out of ceramics, you can operate the engine at high temperature to increase the fuel efficiency. But the problem of ceramics is that although it is a good insulator, it also is very brittle. Very brittle and trick ceramics. So for the ceramics, if you want to use it in engine, and if there is a bump inside the engine all shatter, then your engine disappear, right? So you don't want that. After 20-some, 30-some years of development, they are still working on ceramics engine, but pretty much they shy away from that. They let it go because it is not a good it doesn't have good mechanical property. You got that? Can you help them to distribute it? Yeah. Let me have the, yeah. So ceramics, because of its property, which is easily shattered, it can easily be broken, and that's what it is not used. But people then try to develop composite material for ceramics. They try to make it tougher, not so brittle. So the purpose for ceramics to make into composite is not try to make it stronger, because ceramics is very strong already. Ceramics has very good mechanical property. It is just that it is too brittle, no ductility. Okay, so they try to make composite material for ceramics to increase the ductility, to increase the toughness. That is the objective of ceramics composite material. Ceramics, other than its good insulator, good high temperature property, it is very brittle. It is very, very much defect sensitive. We call that flaw sensitive. Ceramics material, just a little flaw in there, because it is so brittle, it just fractures easily. Okay, so that is another characteristic of ceramics: lightweight, low density of that. But although ceramics is considered insulator, There is one type of material, ceramics, which is perfect for electrical conductivity, good conductor. It's called superconductor. You heard of superconductor? High TC, high temperature superconductor. High TC. TC, superconductor. It is it's called the first one very famously discovered in 1980 some by Paul Chu's group at the University of Houston. It's called 123 compound. It is discovered by Taiwanese. It's called what is his name? He was 国科会主委. What is the name? Paul Chu is Su Jianwu. His student, who really the one discovered 123 compound. He was Paul Chu's student. It just slipped my mind. 2 times ago, 国科会主委. He was at Zhongyan Engineering now. Okay. He discovered the 123 compound. The 123 compound, the reason it is called 123 is barium, copper, yttrium, barium, copper oxide. Yttrium 1, barium 2, copper 3, oxide. Oxygen is 7 minus X. This one has a superconductive behavior at around 90 K, which is higher than liquid nitrogen temperature. So in the old time, when you try to find superconducting behavior for metal, usually you have to cool it down to 10 Kelvin. And 10 Kelvin is very difficult to get. So after they discover the 90 K superconductor, they are able to use liquid nitrogen. And they can do a lot of things. One day, if somebody can, I keep challenging the student, if somebody can find a room temperature superconductor, then everything will change. It is another industrial revolution because superconductor, if you send electricity from power plant to here using superconductor, no resistance. Currently, about 20–30% of the energy is lost, become heat during transmission. If you can save that energy, that is a lot of economy, a lot of money in there involved. Okay, so ceramics, although it's an insulator, there is a type of ceramic material which is a very good electrical conductor. Semiconductor, it is a separate class I classify in here because it normally is not a conductor, but it can quickly become a conductor. Even by light comes in, it becomes a conductor. So that's what silicon-based semiconductor, gallium arsenide semiconductor, are classified into another group. Silicon is not really metal, but it's not really non-metal either. It is right on the borderline because silicon has a energy gap. I mentioned to you last time. This is the valence band. This is the conduction band. and the energy gap is only roughly around 1.1 electron volt. Electron can easily jump from here to here if you shine it with blue light, because blue light, the photon has enough energy to excite electron to go over here. Now, this is by nature. It's called intrinsic. If you put in a acceptor here or a donor there, then you can allow donor to donate an electron in here and easily make it a conductor by doping. Okay? Or if you put an acceptor in here, you can easily allow an electron to jump in here, and you create an electron hole down there. That's a conductor also. Okay, it's a this is called an N-type. This is called a P-type semiconductor. So you can create p-n junction. You can create gate. You can create electronic structure by doing this. The semiconductor we mostly seen is silicon group. But gallium arsenide is called 3,5 compound. It's also a semiconductor, and it has larger band gap. Germanium is also a semiconductor because the electronic structure is the same. I mentioned to you diamond, right? Diamond also could be, it is a semiconductor. You can also have 2,6 compound. When the group 2 and group 6 put together, it could also have the structure. It can also have the structure of silicon, so it becomes a semiconductor also. Okay, so it takes me some time to go over this. I wanted to give you some background about the composite, and that's what we have here. Throughout the process of making material for us to use, there are some ideal material that humans have been looking for. And you can see, if you can easily get it, one thing, okay? You can very cheaply produce. Second, it's energy efficient. It has strong, stiff, dimensional stable. It is lightweight. It has good corrosion resistance and environmental. Very important. Biodegradable. And you can use it again and again. So those are the ideal things people have been looking for. But nothing is like that. It is too perfect. That's what, when we try to use some material, we start to think about, in the case of lightweight, because of energy consumption. In the case of lightweight, well, we can just use the lightweight, but try to improve the strength. And that's how composite starts to come in. Okay. Actually, composite is not new things altogether. Even 30, 40 years ago, people used composite material already. Not because of the lightweight, but because of the good electrical conductivity, but not easily bound together. And that is, if you look at the switch, every switch next to the door there, inside the switch, there are two contact points. We call that electrical contact material. Those are composite material. Those are silver matrix oxide composite material. It actually is cadmium oxide, CDO. It is a silver with CDO put together. Silver is a very good electrical conductor, but silver, if you use just pure silver or even copper, when you switch on in the winter, sometimes you got shocked, right? When you switch on in the winter at dark, you can see some arc comes at the switch. Because when you turn on or turn off, your current, your electric current, when you turn on or turn off, your electric current approach infinity. You have some current going through, so your light is on. But when you turn off, in the very short time, no current. And when di dt becomes infinity, you remember from physics, di dt is proportional to induced voltage. So in the instant that you turn off or turn on, there is very high voltage generated, a few thousand volts, very short time. And since it has very high voltage, that's what you got shocked. Okay? And when you create such a high voltage, that high voltage is enough. It's enough to break up air. And when you break up the air, you create very short period of time, you create very localized plasma. You heard of that? Plasma. That's the way people do sputter deposition using plasma, 电浆, very localized. So sometimes you can smell some 臭味, some odor, because when you break the air oxygen become O, and O atomic oxygen attached to diatomic oxygen give you O3. So sometimes you smell ozone next to it. It's all because of this huge DIDT. And that DIDT creates such a high voltage, break up the air, temperature can be very high. We did some measurement that plasma temperature can be a few thousand degrees C. Very short time, but a few thousand degrees C. Very often you see the electric contact surface will melt. And if we use pure copper, it will melt together. So your switch, 1, 2, maybe within 10 times, it fused together. Your switch no longer is switch. Okay? But if you put in some cadmium oxide in there, then it will not melt together because it has oxide in it. Cadmium oxide is composite material. Okay? That's the reason all the switch, if you take it open, you can see that it has composite material in there. Another very important discovery application for composite is the circuit breaker. Circuit breaker. What is circuit breaker? Anybody? Circuit breaker. What is the name? Circuit breaker. In the old time, when I was a child, you have electricity comes in. But if suddenly electricity goes too high, the fuse will jump, right? Your fuse. What is fuse? Fuse. Button will jump, okay? But then you have no power, and you have to go to the store and buy new fuse. Put it in, then you are okay. Well, that's too troublesome. So now, after they design a circuit breaker. A circuit breaker is a electric contact switch associated with a very quick bimetal, very quick response bimetal. Bimetal is the metal when you have suddenly high current going through, that bimetal will be heat up. And when bimetal heat up to a certain temperature, it will change the shape and will spring open the contact. So the circuit breaker is taking the advantage of the composite material contact and then the bimetal, which will change the shape. And when electricity suddenly increases, when you have sudden surge in electricity, the bimetal will kick in and it will open up. But then all you have to do is go there and switch over, and then your power comes back. Okay. Of course, before you switch back, you better find out what is the reason. If you have two iron, your wife is iron his clothes and you are iron your clothes to iron, then of course power will jump because it is a safety device. Otherwise, you will get fire. Okay, so that is there, and we use composite material for a long time already for this application. Electrical application, plus it has the property that it doesn't fuse together easily. Okay, the design of this composite material will take a million cycles without breakage before they can use. When I after I finished my PhD, I went to work in a company. It's called GTE Laboratory. They are developing new type of circuit breaker material, contact material, electrical contact material, because cadmium oxide is toxic, and people keep using that for a long time. So we are developing new circuit breaker material without cadmium oxide. We use tin oxide, indium oxide, and try to test whether it has good properties or not. And that's the reason environmental issue is getting in here. All right, so what is the composite material? A composite material is typically a man-made material composed of two or more than two different type of component put together. We call that constituent to put together. It's a composite material. Now, composite material, although is defined like that, but actually composite material has been with us for a long time. So if you look at the tree, you cut the tree down, you can see the tree has fiber in there, but have different tissue in it. It's composite material. Okay, bamboo. If you break open bamboo, you can see inside bamboo there are fibers, and there are other organisms around the fibers. That's why bamboo is very strong. Okay, if bamboo is like brick, then it will not be so strong. Our human body is a composite. See, we got bones, and we got muscles, and we got skin to protect it. Without a composite, if we just have meat, then we cannot stand. Okay, so that is also composite material. But the typical way that we engineer define composite typically are those which it's not grow naturally. It's artificially put together. We call that composite material. But generally speaking, you can really think about anything which consists of two or more than two different clearly not in solid solution type put together is called composite for special purpose. For special purpose. Rebar. When we do the building, you put in steel in between, below, and then you put cement on top of that. The concrete structure is ceramics, and this diagram shows the typical group of material in terms of density and in terms of Young's modulus. That is sort of an indication of strength. If you look at here, most of the polymer is lightweight in here, but also the strength, the modulus is not so good. The stiffness is not so good. If you are getting into a wood product, is somewhere in here. Magnesium alloy, still lightweight, is in here. Lead is around there. So we can see different group of material are there. Oops. And this group of material here, we call that engineering material, and porous ceramics is around here. And steel structure should be somewhere in this area there. Nowadays, there are a lot of different composite structure. You can either put in powder or put in fiber inside the other, or you can put in one sheet, another sheet, multiple sheet of material is considered to be composite material. This is the typical way of showing wood fiber and plastic together. And you can see it has this structure. If you have plexiglass, that chipped wood, this is pressed together but give you reasonable strength in it. And when you layer it down into like that, give you the good property. The typical application for metal matrix, after this, there are a number of different slides that I show different application area for metal matrix composite. Aircraft skin, because the lightweight you want, but you want to have good strength. So there are some benefit in here, okay, that you can see. So aircraft skin, bearing, bicycle frame application, both brake rotor. I have some photos down below. Electronics packaging, engine cylinder liner, ground vehicle, just like our typical car there. Landing gear struts. Landing gear is aircraft when they try to land, and there is a shock absorber area. It's called strut. Medical implant application for composite, metal matrix composite. People typically are talking about using titanium matrix composite. Let me see. Space structure. There are some boron fiber reinforced aluminum. I'll show you some photo in there. Those are one table, and you can see by using that kind of structure, what is the benefit of that? You have a copy of this now. This is another table, comes from another source, and you can see different kind of metal matrix composite application. This one here classified that into military application, aerospace application, aircraft, automobile application. Those are already been used. Application area, commercial other application. One very important application is recreational. That is like a tennis racket, bicycle, like ski that they need to use, and like baseball bat, like boat. Give you lightweight, high strength. And the table below shows the real application and the real composite material, metal matrix composite that has been made. Aluminum, we know it is lightweight, but strength is not so good. So they use stainless steel fiber, put it in between, and try to make it. This is in very old times. Nowadays, people are making aluminum with silicon carbide or graphite reinforced, more of that. Some more composite material we made. This are the matrix, copper matrix composite for electrical machinery application. And metal matrix composite with different kind of fiber. Here is aluminum with the silicon carbide reinforcement. They are use it for turbine blade at low temperature area, low temperature turbine area. Copper with carbon reinforcement used in electrical process. Whenever you see copper, pretty much it has electrical application in it. Copper and silver, pretty much you have electrical application in it. Whenever you see aluminum, it's typically structure. You want to make it into some structure. Magnesium also is a lightweight material. There are some more examples. Whenever you see titanium, you can pretty much see it is high temperature, lightweight area. So titanium and silicon carbide. This titanium and silicon carbide have been developed by Air Force, military application, and also by NASA. Because every 1 pound, every half kilogram, or maybe I should use kilogram, every 1 kilogram of material to send it into space, the average cost is about $5,000 US. 1 kilogram is 5,000. So if you want to send, because of gravity, pull it down. So it is a rule of thumb. Every 1 kilogram payload go out into space, it costs about $5,000. Now, if the fuel cost is higher, it could be higher from now. Okay? So you want to make space structure lightweight, and that's what composite material are being considered. again, copper, so it is for electrical application. Those are some information that I think it is good to, at least you have some source. This people have also developed a lot of oxide fiber, 3M. They make a lot of necto fiber, which is for reinforcement. Okay, so that's what I listed out in here. This whole table contains various different type of fiber, and we are going to talk about how those fiber are made for people to use in industry. Let me see, what do I have more before I let you go? In here is making fabricated for metal matrix composite. Okay, this is the space shuttle, and you can see this hatch area is called fuselage area, are made of aluminum composite material. This is space shuttle front view, this is the side view, and this is the structure area that they make it from composite. This is the automobile connecting rod, but people did not use this for every car. Gradually, Toyota is putting in some composite material. Initially, they start to use this in their racing car. The racing car, they want to make it lightweight but high strength. Composite is considered to be still more expensive than steel, a lot more expensive than steel. But racing car, they don't care about the cost, so they can use that. This is the photo shows that connecting rod. And there are some other parts, including connecting rod, including piston. We developed a process using some very special technique, infrared technique, to make composite material. So Toyota wanted to use a composite for their brake rotor. So we had a joint program with Toyota and tried to make, I was making composite about that size, 1 inch. But they wanted in 1 foot, 10 to 12 inch. So I have to restructure my furnace, infrared furnace, to make it into huge. But my process is a much lower cost process, so they had come to us. We jointly worked on for 3 years and try to develop that. But to scale up from 1 inch up to 12 inch is not easy industrially. So after 3 years of collaboration, that Toyota guy, he was sent from Japan into the United States. But he has to go back to Japan, so we stopped the project after that. Okay.